Dear students, welcome to my classroom. In this class, I am going to start a new chapter, Applications of Trigonometry. Students, first you look at this picture. It is a beautiful mountain. Do you know the name of this beautiful mountain? Somebody are guessing? Yes, your guess is correct. The name of this mountain is Mount Everest. Do you know the height of this mountain? The height of this mountain is 8,848 meters approximately. A team of surveyors led by Sir George Everest discovered the height of this mountain. But how did they measure the height of Mount Everest? Do you know? Do you think they used a meter tape to find its height? Trigonometry has been used by surveyors for centuries. They use theodolites to measure angles of elevation or depression in the process of survey. In 19th century, to measure Everest, surveyors used a method called triangulation. Observers examined the peak from several points. Knowing the distance from the points to the mountain, they were then able to measure the angle from Everest's peak to their observation points. In this manner, they find the height of Mount Everest. You can see the instrument theodolite here. So this is the instrument theodolite. In this picture, it is looking small, but it is a big instrument that is used to find heights of the mountains. So anyway, we use trigonometry in various fields and we apply trigonometric formulas and trigonometric ratios in different fields. So in this chapter, we learn the applications of trigonometry. So our new chapter is applications of trigonometry. So before going to this chapter, we have to familiar with some important terms. So there, first one is horizontal line, line of sight, angle of elevation, and angle of depression. So first of all, what is horizontal line? We know the meaning of horizontal line, but how can we use in this chapter? That's the important. So it's a beautiful lawn. So on this lawn, a person stands and he is looking straightly. When he is looking straightly, the path in which he see is called horizontal line, like this. So this is called horizontal line. Next, line of sight. What is line of sight? So now the person is looking somebody. What is he is looking? He is looking a flight which is flying in sky. So now the line joining the person's eye to the object, that is the flight, is called line of sight. Line of sight. Now we can define the line of sight as the line from our eyes to the object we are viewing is called the line of sight. The line from our eyes to the object that we are viewing is called the line of sight. Next, so do you know this? It's Eiffel Tower, isn't it? Now this person who is looking horizontally, now starting to looking at the top of the tower, like this. Now this line of sight is making some angle with horizontal line. This angle is called angle of elevation. So we can define the angle of elevation as the angle formed by a horizontal line and a line of sight to a point above the line is called the angle of elevation. Okay. Now Another point. So here it is a beautiful building, and in front of the building there is a car. Now the person is at the top of the building. Now he is looking straightly. So this is a horizontal line. Now he started to looking at the car. Now this is the line of sight. Here also the line of sight is making some angle with horizontal line. Now this angle is called angle of depression. It is called angle of depression. So we can define the angle of depression as the angle formed by a horizontal line and a line of sight to a point below the line is called the angle of depression. Angle of elevation is above the horizontal line and angle of depression is below the horizontal line. Okay. So these are the important terms that we are used in this chapter. Next, some important points are there. Look at this. When we want to solve the problems of heights and distances, we should consider the following. In these applications of trigonometry, we are going to solve some problems. But before going to solving the problems, we should consider some important points. The first thing is all the objects such as towers, trees, buildings, ships, mountains, etc. shall be considered as linear for mathematical convenience. It means that some towers are triangle in shapes, some towers are rectangle in shapes, and we know the trees have branches, they had curves, isn't it? But for our convenience, we take all as linear. They are in linear shape. Okay. And the second thing is the angle of elevation or angle of depression is considered with reference to the horizontal line. Already we seen this point. The angle of elevation or angle of depression is count with respect to the horizontal line. And the third thing is the important thing, the important point. The height of the observer is neglected if it is not given in the problem. So if the height of the observer is given, we have to consider the height. But if it is not given, we need not to consider that height. Okay. So these are the important points that we must remember before solving the problems of applications of trigonometry. So let us start exercise 12.1. First problem. A tower stands vertically on the ground. From a point which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? This is the question. So before solving this type of problems, we must imagine the situation according to the problem. That is important thing. We must imagine the situation. So let us imagine the situation together. So here it is a beautiful lawn and there is a tower stands vertically on the ground, and from the point which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? It is the question. So first we have to draw the picture in lines. That is, it is the ground and it is the tower and it is line of sight, and the measurements are 15 meters. That is distance between the observer and the foot of the tower is 15 meters. and the angle of elevation is 45 degrees. And here we have A is the point of observation, BC is the top of the tower, height of the tower. We have here 90 degrees. Now, using this picture, we have to find the height of the tower. Okay. So before solving the problem, we must write what is what. That is, let A be the observation point and BC is the height of the tower. Now, what is given here? Angle BAC is equal to 45 degrees and AC is equal to 15 meters. Now, in this triangle ABC, we know angle A and adjacent side with respect to the angle A, that is AC, which is equal to 15 meters. And here we have to find the height, that is BC. What is BC here? The height of the tower. So we have to find BC, which is the opposite side with respect to the angle A. So with respect to the angle A, we know adjacent side and we have to find opposite side. And what is the trigonometric ratio regarding both adjacent and opposite? We know it's tan or cot, because tan theta is equal to opposite by adjacent and cot theta is equal to adjacent by opposite. So from this triangle ABC, now we have to write either tan A or cot A, because our known value is adjacent side and our required value is opposite side. That's why from triangle ABC, we have to write tan A, which is equal to opposite by adjacent, that is BC by AC. Now write the values of A and AC, which we are now. A is 45 degrees, AC is 15 meters. So tan 45 is equal to BC by 15. And we have tan 45 is equal to 1. So write 1 instead of tan 45. Now by cross multiplication, we get BC is equal to 15. And what is BC here? BC is the height of the tower. Therefore, the height of the tower is 15 meters. That is the solution of the problem. Okay. And now, let us see the second problem. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground by making 30 degrees angle with the ground. The distance between the foot of the tree and the top of the tree on the ground is 6 meters. Find the height of the tree before falling down. So this is the question. And imagine the situation. First we have to imagine the situation. So this is the ground and it's a tall tree, and due to storm it bends down like this. Some part of the tree broken and laid on the ground, and the distance between the point at which the tree touching the ground and the foot of the tree is 6 meters. Okay. Now here we have to find the height of the tree before falling down. That is height of the tree which stands and the height of the tree which is fell down. Okay. So now draw the lines according to the situation. Here the angle of elevation is 30 degrees. Here the angle is 90 degrees. Let A be the top of the tree, B be the bottom of the tree, C the point of observation, or what you see here? The point at which the broken part is touching the ground. Okay. And this is the broken point. Now, first write what is what. A be the top of the tree and B is the bottom of the tree. D is the point at which tree was broken. C is the point at which broken part touched the ground. And here the measurements are angle DCB is equal to 30 degrees. BC is equal to 6 meters. AD is equal to DC. Why? AD and DC both are equal to broken part of the tree. AD and DC both are equal. Now, from triangle DBC, what we have to find? Here the required height is height of the tree before falling down. That is the length of AB we have to find. But what is length of AB? Length of AB is sum of both AD and DB. And we have AD is equal to DC. So we have to find both DC and DB. DC is hypotenuse of this triangle. DB is opposite side with respect to the angle C, which we know that 30 degrees. Now we have to find both opposite and hypotenuse. First let us find opposite. We know adjacent and we need opposite. So we have to take tan, opposite adjacent, related trigonometric ratio, tan. So tan C is equal to dB by BC, opposite by adjacent, dB by BC. And C is 30 degrees, BC is 6 meters. Right, substitute these values. Tan 30 degrees is equal to dB by 6. And the value of tan 30 is 1 by root 3 is equal to dB by 6. So the dB is equal to 6 by root 3. Now let us find the length DC, that is hypotenuse. We have adjacent and we need hypotenuse. So the trigonometric ratio related to both adjacent and hypotenuse is cos. So take cos C. Cos C is equal to adjacent by hypotenuse, that is BC by DC. So substituting C is equal to 30 degrees and BC is equal to 6. Now the value of cos 30 degrees is equal to root 3 by 2. So root 3 by 2 is equal to 6 by DC. DC is equal to 12 by root 3. Now the height of the tree is AD plus DB. Okay. But AD is already equal to DC. So this one is equal to DC by DC plus DB. Now DC is equal to 12 by root 3 plus DB is equal to 6 by root 3. Now sum of these two is equal to 18 by root 3. So as we have the denominator as root 3, write 18 in multiples of 3. That is 6 into 3. Now 3 can be written as root 3 whole square. Okay. Because root 3 whole square is again equal to 3. That's why we are writing is here 3 is equal to root 3 whole square. Now 1 root 3 will be cancelled and we remain with 6 into root 3. So therefore the height of the tree before falling down is 6 root 3 meters. Okay students, that's all for today. See you in next class. Bye.